on the one hand, to be efficacious in humans trying to break addictive behavior by increasing or by methods that cause increased glutathione in this region of the brain. And they can break behavior to both cocaine and nicotine. We know that Protandim elevates GSH levels, and it's in part by increasing that turnstile protein. And what we found is that, or what has been found by others, is that that turnstile protein is also important in preventing this longing sensation from developing in the brain. So the turnstiles are absolutely essential. And then finally, anecdotal evidence, much of which I gleaned from you at the last Elite Academy, and a lot since then, suggests that indeed Protandim might be a useful adjunct, and that clinical trials to really prove this are probably an appropriate question for us to ask. So that's where we are. Again, many of you who have connections to smoking cessation clinics and so forth have contacted me. I think we're well on our way to providing an answer for this. And what an answer that would be. I mean, this is a real need in society at a number of levels. And there is no good way, some of you probably stopped smoking in your lives, and it's not an easy thing. It's a tough thing, and I have total sympathy with those who are trying to do that. All right, that's number one. Number two, I want to inform you of a new human clinical trial. This is about the use of Protandim in the metabolic syndrome. And I'll tell you more what metabolic syndrome is if you're not familiar with it. The principal investigator on this project is one of my colleagues at the University of Colorado in Denver, Robert Eckel. And you probably don't recognize his name, but let me tell you who he is. He's one of America's foremost endocrinologists studying heart disease and metabolic syndrome. In 2005, Bob Eckel was the president of the American Heart Association. All right, so this is not chopped liver. This is a major study by a major player in the field, and it's just beginning. What is metabolic syndrome? It's a combination of disorders that increase the risk of developing cardiovascular disease, heart disease. It affects probably at least 20%, some estimate 25% of the American population. And it increases with age. And there are a number of, every organization like the American Heart Association and many others around the world have their criteria for diagnosing or predicting when you have metabolic syndrome. And usually there are these four conditions at the bottom: central obesity, elevated triglycerides, good HDL, low measure of the good form of LDL, of cholesterol, hypertension, high blood pressure, and fasting plasma glucose that's higher than it should be. That is hyperglycemia, which is an indication of developing diabetes. And usually two of those four is enough to say you're at risk for cardiovascular disease, you have metabolic syndrome. If you're not, this sounds like a Jeff Foxworthy joke, but if you're not sure if you have metabolic syndrome or not, you can look in the mirror. This is what it looks like. It's not a pretty picture, and it's called central obesity for the very obvious reason. It's what physicians describe as an apple shape. And so a person may have limbs that look pretty normal, so they don't look like a morbidly obese person, but all that obesity is right in the gut. It's central obesity. So that's what metabolic syndrome is. If you want to learn more about this study, not a lot more, but some more, there's a website run by the National Institutes of Health. And again, this is not the company's website. This is not somebody's blog. This is the website for clinical trials in the United States, and it's put there by the National Institutes of Health. You can go there, clinicaltrials.gov, and look at this. You can type in Protandim, And you'll see 3 studies listed. This is the newest one and one of them, and it tells you who's sponsoring it. You might note that one of the sponsors there is SomaLogic. It's another company. Their interest is in how to measure the proteins that your body produces, called proteomics instead of genomics. And they're using in this trial, their contribution is their new technology to measure more than 850 proteins in the plasma of these people, in the bloodstream of these people. And their hope is to generate a specific profile where they can diagnose metabolic syndrome just by a blood draw, not just metabolic syndrome, but they hope ultimately maybe hundreds of diseases by measuring these 850 different parameters. So that's an interesting coming together of technologies. And let me say it again, Bob Eckel, former president of the American Heart Association, chose Protandim to do this study. That's the only treatment being used. And if you put in Protandim, as I said, you'll turn up 3 such projects. One here is on non-alcoholic steatohepatitis, which means inflammatory liver disease. It's also a bit related to metabolic syndrome. And the other one is the use of Protandim to change lung glutathione levels in alcoholics who are oxidatively stressed because of the chronic alcoholic consumption. So all 3 of these are there. You should refer people to these. If you have a competitor, another product, and they want to take you on, ask them if they've got one clinical trial on clinicaltrials.gov, and ask them if they've got published peer-reviewed papers. And speaking of those, there's another one coming out in about a week. It's already available online. And that's the third thing I want to talk to you about. The dietary supplement Protandim decreases plasma osteopontin, that's a profibrotic factor, and improves markers of oxidative stress in muscular dystrophy MDX mice. All right, Duchenne muscular dystrophy is a human disease, and we have a mouse model of it that the origin is very close. The disease looks a bit different in mice than it does in humans. One of the reasons is as the muscles fail, a muscle in a mouse has very little stress load because a mouse weighs 20 grams and you weigh 70 kilos or more. If you have a metabolic syndrome, maybe a lot more than that. So this disease looks a bit different, but it's a very close biochemical model. And what was seen here, this was conducted, by the way, by my colleague Brian Singh when he was at the University of Colorado, Denver. As this study was in progress, about to end, he took a new job at Harvard University Mass General Hospital, and that's where the paper was written. So it's from Mass General and University of Colorado. One of the things we measured was T-bars. And again, every subsequent publication, every peer-reviewed study should hearken back to the first one and connect dots with studies in between. And this one does. You may recall in our human study published in 2006, Protandim decreased T-bars by 40% in humans who didn't have a particular disease. They were just getting older. It looked at young and old. These are pretty young mice, but they have a disease. They have this muscular dystrophy. Protandim decreased their plasma T-bars by 48%, okay, confirming that. Protandim decreased this profibrotic factor by 57%, right? This is not new either. This was done in the Virginia Commonwealth University study published last November, the one David mentioned in the journal Circulation. And virtually the same kind of result, Protandim in rats in that case and in mice in this case, reduced this profibrotic factor by 57%. Here's an enzyme I hadn't talked to you much about, but we actually measured it after that first human trial was published because we still had the samples. There's an important protective anti-atherosclerosis enzyme in your plasma, abbreviated PON1. And it's associated with the good form of cholesterol, and it prevents the oxidation of the bad form of cholesterol, which promotes plaque buildup in the arteries. And here is an example. This is not by gene regulation. It's actually by preventing the inactivation of PON1 by lipid peroxidation products related to T-bars. So T-bars is a bad thing. One of the bad things it can do is inactivate good essential enzymes. So the PON1 in these untreated animals is lower than it should be. When they're treated with Protandim, that inactivation is prevented, the PON1 levels rise, and now you have the adequate amount of protection by PON1. Is PON1 important? This is a paper that says low paraoxinase, PON1, predicts cardiovascular events in a study conducted of patients at risk for heart disease. So yes, and I've shown you a similar paper before showing that T-bars elevation also predicts cardiovascular events. This is a compilation of measurements of PON1 and a number of diseases, and I'm not going to read them all to you, but you can see the first one after the normals, which has a level of normalized here of 100%, is metabolic syndrome, and followed by diseases like autism, type 2 diabetes, a whole bunch of things you can read there. And at the very opposite end of the spectrum is the normal people in our first human study who were treated with Protandim. And you can see that their PON1 is significantly elevated above the normal level and way above the level seen in these diseases. And then finally, I want to show you a very interesting measure, and I think you can see that. Okay, these are magnetic resonance images, an MRI, of the calf muscle, the lower leg of these mice that have this muscular dystrophy. And the upper two panels show two of these MDX mice that were treated with Protandim. The bottom two panels show MDX mice that were not treated. And I don't expect you to be able to read MRIs necessarily, but I want to point out what's different here. You can see there are white areas, and these are probably areas of fibrosis within this muscle called the gastrocnemius muscle. It's your calf muscle, and the corresponding muscle in these animals. And in the upper level, in the upper Protandim treated animals, you can see much less of that. And if the computer can measure the areas of white, quantify it. And what you see here is there was a 38% decrease in the Protandim treated animals of this so-called anomalous MRI area. This part of the study actually fell just short of statistical significance only because there weren't enough surviving control animals to bring that number down. There were only 10. And these doing MRI on a mouse is fairly difficult. He has to be anesthetized. And often the ones that died during that were because they died during the anesthesia. It's a little more difficult to give anesthesia to a mouse than to a human. But in summary, this study confirmed things you already know. Protandim decreases T-bars. Protandim decreased osteopontin, a pro-fibrotic marker. Protandim increased this new enzyme I'm talking about, paraoxinase 1, PON1, a protective anti-atherosclerosis enzyme. And Protandim decreased the anomalous MRI signals in the leg muscles of these animals. So thank you very much for your attention, and I hope you learned something. Thanks.